Today, I invite you to explore the remarkable story of Sahelanthropus tchadensis, one of the oldest and most enigmatic members of the human family tree. In this narrative, I will guide you through its discovery, unique anatomy, ancient environment, and the profound evolutionary implications of this fossil found in the Sahel region of Chad. This fossil, often called Toumaï, is not merely an ancient remnant. It is a window into a time nearly 7 million years ago, when the earliest steps toward modern human traits were taking place. This journey begins at an era when our distant ancestors embarked on a path that would eventually lead to modern humans. The fossil of Sahelanthropus tchadensis presents a fascinating blend of primitive traits combined with emerging characteristics that hint at a transition toward bipedalism. Its discovery challenges long-standing ideas, extending the known range of early hominins beyond East Africa and inviting us to reconsider where and how our lineage began. Travel back to the year 2001, when in the vast expanse of the Toros-Menalla region in Chad, an extraordinary discovery was made that would forever alter our understanding of human evolution. In the once lush landscapes of the Sahel, researchers unearthed a nearly complete cranium, subsequently nicknamed Toumaï. This fossil, dated between 6.8 and 7.3 million years ago using advanced cosmogenic nuclide dating techniques, stands as a silent witness to an epoch long past. Imagine a world where gallery forests, verdant woodlands, and winding waterways intermingled to create a vibrant ecosystem. It is within this intricate tapestry of life that Sahelanthropus tchadensis made its indelible mark. Its discovery challenged prevailing theories, revealing that early hominins were not confined solely to the well-trodden cradles of East Africa, but also roamed the heartlands of Central Africa. In meticulous excavation sites, scientists carefully sifted through layers of sediment, piecing together clues from ancient soils and fossilized remains. Their effort unveiled not only the fossil itself, but also whispered hints of a rich environmental narrative. Rivers that once meandered gracefully, forests that echoed with the calls of myriad creatures, and skies that bore witness to an unfolding drama of evolution. This groundbreaking find sparked debates and inspired further exploration into regions previously thought barren of such ancient relics. The discovery of Toumaï has become a cornerstone, prompting researchers to re-examine established geographical boundaries and ecological assumptions. With every carefully documented fragment, our understanding of early hominin life grew richer and more nuanced, inviting us to imagine the myriad ways our ancestors adapted to shifting, dynamic landscapes. Every new piece of evidence from Toros-Menalla adds another layer to our understanding of a world that has long since vanished, yet still whispers its secrets through enduring stones and ancient soils. This remarkable discovery reshapes our view of early human history, opening new avenues for inquiry and challenging assumptions about where life began. Thus, the find continues to fuel passion for reconstructing our deepest origins and spark endless inquiry. In our journey through deep time, the fossil of Sahelanthropus tchadensis reveals a fascinating mosaic of features bridging the gap between apes and humans. A careful examination of its cranium uncovers a robust structure, highlighted by a pronounced brow ridge known as the supraorbital torus, which underscores its ancient heritage. Intertwined with these primitive traits, however, are subtle signs of transformation. Most notably, the forward placement of the foramen magnum, the critical opening at the base of the skull where the spinal cord passes, hints at an adaptation for an upright posture. Alongside these cranial clues, the dental anatomy provides compelling evidence of evolutionary change. The fossil's canines are reduced in size compared to those of modern apes, and the molars boast a thick, protective enamel layer. These dental characteristics suggest shifts in diet and social behavior that align more closely with traits observed in later hominins. Yet the story does not end with the skull. A fragmentary partial left femur, discovered in proximity to the cranium, adds another layer of mystery. Though its structure does not conclusively prove habitual bipedalism, it raises the intriguing possibility that Sahelanthropus experimented with a range of locomotor patterns, balancing between climbing and walking on the ground. This blend of ancestral features and emerging adaptations paints a picture of an evolutionary experiment, a creature caught in a transitional phase between its ape-like forebears and the fully bipedal hominins that would follow. Each anatomical detail, from the sturdy brow to the subtly shifted spinal canal, whispers a story of change over millions of years. In every ridge and tooth, we find hints of the gradual processes that slowly sculpted our distant past, offering us precious clues about the origins of modern human form and function. Thus, every fossilized feature becomes a chapter in the grand narrative of evolution, inviting us to decode the silent language of ancient bones and to appreciate the slow, steady artistry of natural selection that has shaped our very being and reveal endless wonders. Stepping deeper into the tapestry of time, the implications of Sahelanthropus tchadensis for the human evolutionary timeline are profound. With an estimated age of nearly 7 million years, this fossil occupies a critical position near the divergence of the human and chimpanzee lineages. Its discovery compels us to rethink the chronology of key evolutionary developments. The anatomical hint of an anteriorly positioned foramen magnum implies that adjustments toward an upright posture had already begun, challenging the expectation that bipedalism emerged only in later hominins. This ancient relic reminds us that evolution is not a series of sudden leaps, but a gradual process marked by countless small adaptations. The reduced size of its canines and the thick enamel on its molars suggest dietary and behavioral shifts that differentiate these early hominins from their ape relatives. Such traits indicate that even in its early stage, Sahelanthropus was part of a lineage experimenting with the foundations of what would later characterize our species. By redefining the timeline, this fossil encourages us to envision an evolutionary tree with multiple branches diverging and interweaving, rather than a single linear progression. In reflecting on this discovery, one can imagine how our ancestors navigated diverse landscapes, shaped by a myriad of environmental challenges and opportunities. The mosaic of traits preserved in this fossil is a silent testament to the nuanced interplay between anatomy and adaptation over millions of years. Thus, Sahelanthropus tchadensis not only repositions a key moment in our timeline, but also enriches the story of human evolution by highlighting the complexity and gradual nature of change. Continuing our exploration, we now compare Sahelanthropus tchadensis with other early hominins, including Tugenensis and Ardipithecus ramidus. Each species contributes uniquely to our understanding of early evolutionary experiments, offering contrasting yet complementary anatomical narratives. Sahelanthropus, with its blend of primitive and derived traits, presents a picture of an early experiment in adaptation. Its reduced canines and forward-shifted foramen magnum suggest early tendencies toward bipedalism, albeit in a mosaic form that leaves room for debate. In comparison, Tugenensis shows clear evidence of habitual bipedalism, notably through its femoral structure, which indicates a more pronounced commitment to upright walking. Ardipithecus ramidus, on the other hand, embodies a balance between arboreal and terrestrial adaptations, with dental and skeletal features that hint at a diverse repertoire of locomotion. These comparisons reveal that the path to modern human anatomy was not uniform, but involved multiple evolutionary experiments running in parallel. The detailed study of these fossils encourages us to view human evolution as a branching network rather than a single linear progression. Each discovery adds a vital brushstroke to an expansive evolutionary canvas, illustrating the complex interplay between environment, anatomy, and behavior. The differences among these species challenge simple narratives, reminding us that early hominin evolution was a dynamic and multifaceted process. Together, these comparisons enrich our understanding of the past, highlighting that while some early hominins may have experimented with upright walking, others pursued different adaptive strategies. This diversity fuels ongoing scientific inquiry and inspires us to continue unraveling the intricate story of our origins. These collective insights challenge us to broaden our perspective on human evolution. They show that the journey to our modern form was not a single isolated event, but a rich tapestry of divergent paths, each contributing to the complexity of our lineage, truly inspiring our lifelong quest. Shifting focus from skeletal remains to ancient landscapes, we explore the paleo environment of the Sahel region, where Sahelanthropus tchadensis once roamed. In the late Miocene, this area was a dynamic mosaic of gallery forests, open woodlands, and meandering rivers that nurtured a vibrant diversity of life. Rather than the barren, arid lands we see today, the ancient Sahel was a lush and varied realm, providing ample resources and shelter to its inhabitants. Within this rich environment, fluctuating climatic conditions created diverse habitats that demanded adaptability from every living creature. Early hominins, including Sahelanthropus, would have experienced a world of verdant foliage, shifting watercourses, and a climate in constant flux. The interplay between dense vegetative patches and open clearings offered both opportunities for growth and challenges for survival. It is in this setting that our ancient ancestors honed their skills, adapting their diets and behaviors to make the most of their surroundings. The traces left in ancient sediments and fossilized flora reveal a landscape marked by change, one where seasonal rains and dry spells dictated the rhythm of life. The abundance of water sources and the presence of diverse plant life not only supported animal communities, but also played a pivotal role in shaping the anatomy and behavior of early hominins. As we reconstruct this world, we see that the once lush Sahel was a crucible of evolutionary innovation. This vivid portrait of the past reminds us that the environment is a powerful force in evolution, continually molding life through its shifting conditions. Through the lens of paleoecology, the story of Sahelanthropus gains depth, illuminating the resilience and adaptability that characterized our early ancestors and setting the stage for the evolutionary journey that followed. This ancient environment continues to inspire our understanding and fuels our imagination about life's unfolding history with enduring mystery. Emerging from the interplay between anatomy and environment, the story of bipedalism emerges as one of the most intriguing chapters in human evolution. Among the leading theories, the savanna-based hypothesis suggests that as dense forests receded, our ancestors adopted an upright posture to better scan open landscapes for resources and potential threats. In contrast, some researchers argue that bipedalism may have roots in arboreal behavior, where standing upright provided advantages in navigating the complex structure of forest canopies. Sahelanthropus tchadensis offers a unique perspective on this debate. The forward placement of its foramen magnum hints at an adjustment in head posture, an anatomical change that could facilitate bipedal locomotion. However, the partial femur attributed to this fossil does not conclusively confirm habitual upright walking, leaving open the possibility that this early hominin was still exploring various modes of movement. This ambiguity has led to spirited discussions among scientists about whether Sahelanthropus represents an evolutionary experiment with bipedalism or merely an intermediate form retaining arboreal adaptations. Imagine a world where every slight modification in posture brought significant survival advantages, whether for spotting predators or reaching for food. Such incremental benefits, accumulated over countless generations, gradually paved the way for the development of an efficient, upright gait. In reflecting on these theories, we see that bipedalism likely emerged not through a sudden revolution, but as a gradual mosaic process influenced by a shifting environment and evolving anatomical structures. This compelling narrative reminds us that even subtle anatomical shifts can have profound evolutionary consequences, shaping the destiny of our species. Thus, the study of these ancient adaptations enlightens our understanding of human evolution, providing a window into how every small change has contributed to the remarkable journey toward modernity and forever inspires progress. Reflecting on the broader tapestry of evolution, Sahelanthropus tchadensis significantly impacts our understanding of hominin diversity. This fossil challenges the notion of a simple, linear progression from primitive apes to modern humans, instead revealing a complex branching of evolutionary experiments. The mosaic of traits, merging both ancestral features and early markers of change, suggests that multiple hominin lineages emerged, each pursuing distinct adaptive strategies. By showcasing a blend of primitive and derived characteristics, Sahelanthropus reminds us that our early ancestors were not a homogeneous group, but a varied collection of species exploring different paths. Its existence encourages scientists to rethink established models and consider the possibility of parallel evolutionary routes. Such diversity implies that rather than a single orderly progression, early human evolution resembled a rich, intertwined network of experiments in survival and adaptation. This reimagined view of our past transforms how we study human origins. It opens new avenues for research and broadens the scope of inquiry into how early hominins engaged with their environments. The fossil's intricate combination of features not only enriches our scientific narrative, but also deepens our appreciation for the complexity of life. Ultimately, Sahelanthropus tchadensis stands as a testament to the varied and dynamic nature of evolution, urging us to look beyond simple stories and embrace the profound diversity that underpins our heritage. This fossil continues to expand our vision of early humanity beyond all expectations. In closing, the story of Sahelanthropus tchadensis weaves together discovery, anatomy, ancient landscapes, and the profound processes of evolution into a narrative that transforms our understanding of human origins. This remarkable fossil, uncovered in the heart of the Sahel, bridges the gap between our distant ape-like ancestors and the modern traits that define our species today. Its blend of primitive features and early adaptations challenges conventional linear views of evolution, inviting us instead to see a richly branching family tree of early hominins. As we reflect on this ancient relic, we are reminded that evolution is a gradual, intricate process where every small change contributes to an extraordinary journey. Sahelanthropus tchadensis inspires us to look deeper into the past, to question established narratives, and to appreciate the complexity of life's continuous transformation. Its legacy endures, fueling scientific inquiry and igniting our curiosity about the myriad paths that have led to modern humanity. Through this fossil, the silent voice of our ancestors speaks, urging us to remain ever curious and inspired.